Hello, in this video we'll solve two rational inequalities. So the first one we have is x minus 2 over 2x plus 1 less than negative 1. So the first thing we do is we add 1 to both sides. So we get x minus 2 over 2x plus 1 less than 0. And then we look for the LCD, and in this case it's 2x plus 1. So we'll have x minus 2 over 2x plus 1 plus 2x plus 1 over 2x plus 1. Making it one least common denominator, 2x plus 1, we get x minus 2 plus 2x plus 1 less than 0. Now we add the like terms, we get 3x minus 1 over 2x plus 1 less than 0. So in this case, we could have this rational function, which is 3x minus 1 over 2x plus 1 equal to 0, and we have 3x minus 1 equal to 0, meaning that x equal 1/3. So if x is 1/3, the whole thing equals 0, and 2x plus 1 should never be equal to 0, otherwise the whole rational function will be undefined, meaning that x should not be equal to negative 1/2. Now we use the table to check the sign of this rational function. So the number line for x, or like the x-intercept, goes from negative infinity to infinity. And somewhere in the middle we have a negative 1/2, which is the smallest, come first, and then 1/3. So we're going to check what happened next to this two critical points. So the first term we have is numerator, which is 3x minus 1. Then we have the denominator, which is 2x plus 1. And then the rational function that we're going to check the sign for is 3x minus 1 over 2x plus 1. And we need to know when is this less than 0. That's the question mark. So first, 3x minus 1 is equal to 0. When x is 1/3. If x is 1/3, then this value is equal to 0. And 2x plus 1 is equal to 0 when x is negative 1/2. Then you test the values of x when they are less than 1/3 for here, and we're going to see that they're going to be negative. And any value after 1/3, for example 2, you substitute 2 for x, you get 2 times 3, which is 6 minus 1, positive 5. So you get positive values, and you could choose different values if you wish. And the same here, you choose any number less than negative 1/2, for example negative 4, and 2 times a negative 4, you'll have a negative 8 plus 1, which is negative 7. So these values on this side is always negative for 2x plus 1, and the x values after negative 1/2, they will be positive. And again, you could choose a 0, for example. 0 is greater than negative 1/2. So if you choose 0 for x here, we're gonna have 0 plus 1, which is just 0, which is just positive 1. And so the values will be a positive number. So this is like the x values. You choose that point, any points between this interval, and then you plot the point here, and you're gonna have a positive value. So now the sign of the function that concerns us. So any value of x between negative infinity to negative 1/2 will make the numerator negative and the denominator negative. So negative over a negative makes a positive. Any value between negative 1/2 and 1/3 will make a numerator, which is 3x minus 1, a negative, but the denominator, which is 2x plus 1, a positive. So a negative, because negative over positive is a negative. Just want to write this one neatly. And here we have any value between 1/3 and positive infinity. If you will make the numerator positive, denominator positive, that means the whole thing is a positive value. So here, to solve for this, for what value this function is less than 0, so here is less than 0 meaning negative, these are the values that will make this function less than 0. So the answer would be from -1/2 to 1/3. One thing I did not talk about is that the value of -1/2 will make this an irrational function undefined. So I write, either put 2 bars or anything that will remind you not to take x equal 1/2 as a solution, which it should always be open, or it should have a parenthesis instead of a bracket. And for the other value here, 1/3 will make this rational function equal to 0. So if the function was equal, then I will put a bracket because I choose that to be equal to 0. So let's see the other example here. So the function is given, the two rational inequality here. So first we move this rational function on the other side, and we set it equal less than or equal to 0. Find the LCD, and then we'll have when you add the like terms, we're gonna have x minus 5 over x plus 1 times x minus 1 less than or equal to 0. And the same thing, first we look for those critical points. What makes this equal to 0 is when x minus 5 equals 0, which is when x equals 5. And what makes x plus 1 equal should not equal 0 because it's in denominator. So I remember that x should not be equal -1, and x minus 2 should not be equal to 0, meaning that x should never be equal to 2. Then I use the table as well, and by the way, this table help us find the graph of any rational functions as well. So here is the number line, and again, how many terms we have? We have the x minus 5, we have the x plus 1, the x minus 2, and the x minus 5 over x minus 2, x plus 1. So then this critical point right here, we find them on the number line. The smallest one should be -1, then there is a 2, and there is 5. And it's important to have them in the right order, from smallest to largest. So this numerator right here, x minus 5 is equal to 0 when x is 5. And this one, x plus 2, should never, the function itself should never be equal to 0, but the value of x plus 1 equals 0 when x is -1. X minus 2 should be equal to 0 when x is 2. And now our concern is to find the sign for the whole rational function. We know that this rational function equal to 0 when x is 5. So here is when x equal to 5 is equal to 0. And I know that I should never choose -1 or 2 as values for the function because they are undefined. I just mark them this way so I know. Now the sign. So any value, again, less than 5 will make this x minus 5 negative, and then any value after the 5, which is 6, like 6 minus 5, we get positive. Here as well, any value less than -1, which is -2, will have this value a negative, and then any value for x after -1 will make the whole x plus 1 a positive value. The same here, so we're gonna have a negative, any value less than 2 will make this a linear function a negative, and any value after the 2 will make it a positive. So again, in this interval from -infinity to -1, if you choose any x between -infinity to -1, you will have a negative over a negative times a negative. So 3 negatives makes negative. And again, from -1 to 2, if you choose a value right here for x, will make the x minus 5 negative. It will make the x plus 1 a positive, and it will make x minus 2 a negative. So negative over positive times a negative, so two negatives basically is positive. And here we have a negative, is the same way, negative over positive times positive, so negative over positive is negative. All positives will make it positive. So here now, what we care about is when is this less than or equal to 0. That means a negative or equal to 0. So here is a negative and here is again. So if x in this interval, it will make the rational function negative, and if x in between 2 and 5, it will make this function also a negative. So the solution here we have is, so I'm gonna write it right here. Oops. So I write the function, I write the solution right here, just so we closer. So we have from negative infinity to negative 1, and then we have union 2 to 5, and then I'm gonna have a bracket here. So see that I did not choose a 2 or a negative 1 as part of the solution, even though it's equal, and because these two values makes the function undefined. And then I choose a 5 because 5 makes it equal, makes this function equal to 0. So here is the solution to this irrational inequality, and I hope this is helpful.